All right, let's get into it. We hear so much about making AIs bigger, stronger, more powerful. But what if the next giant leap isn't about more brute force? What if it's about being smarter with the incredible power we already have? That's what we're exploring today, a brand new framework that's basically an AI project manager for really complex tasks. And it's a fantastic question, isn't it? I mean, we've got these large language models that are just mind-blowing. They can write code, they can answer PhD-level questions, but the moment you try to chain them together for a big multi-step project, things can get clunky and honestly super expensive. What's going on there?
Well, it's because AI's kind of growing up. It's moving past being a simple question and answer machine. We're now asking it to tackle real-world jobs that have lots of different stages. Things like building a piece of software from scratch or doing deep research that takes a whole series of steps to get right.
Let's make this real with a super common example: retrieval augmented generation. First, you need an AI to act like a master librarian, digging through a mountain of data to find the exact right documents. Then you need another AI to act like a world-class expert, taking those documents and writing the perfect summary or answer. Two totally different jobs, two distinct steps. And that right there frames the problem perfectly. It's not a technology problem, it's a management problem. How do you build the best possible AI team for any given project? You got to pick the right model for each specific task, and you have to do it without just, throwing money and resources down the drain.
So this leads us to what we can call the compute budget puzzle. Just imagine for a second that you're a project manager. You've got a fixed budget, but instead of dollars, it's measured in raw computing power. How do you spend that budget to assemble your AI dream team and get the absolute best results?
And yeah, in the AI world, a compute budget is exactly that. It's the total amount of processing power you're allowed to use for a task. It's your hard limit. Every single thing an AI does, every search it runs, every single word it generates, it all costs something from that budget. And this is where the really tough decisions come in. For any step in your project, do you hire the expert? That massive 70 billion parameter model that gives you incredible quality, but man, is it slow and expensive. Or do you go with the scrappy junior model? A smaller 3 billion parameter one that's super fast and cheap so you can let it try over and over again to get the answer right? Now here's where your brain might explode a little bit. For a pretty simple 3-step software project, let's say coding, testing, and debugging, if you have just a couple of model choices and budget levels for each step, you are looking at over 1.8 million possible team combinations. You can't just guess. Trying to find the best one through trial and error? Forget it. It's literally impossible. And the researchers behind this paper, they nailed the two big problems perfectly. First, as they say, the search space, all those millions of combinations, is just massive. But second, and this is so important, the subtasks aren't independent. They're connected. A choice you make in step 1 has a ripple effect on what's needed for step 2 and step 3, and so on. So how in the world do you solve this puzzle? Well, this is the cool part. After running a ton of experiments, the researchers found there are hidden patterns. They unlocked 3 fundamental insights, a kind of secret playbook for managing AI teams efficiently. Okay, rule number 1, different jobs need different tools. This sounds obvious, but get this. For some tasks, like that librarian job of retrieving documents, a big, powerful model is way better. But for other tasks, like actually writing the answer, a smaller, faster model that gets more chances can actually outperform the big guy. It's not a one-size-fits-all game. Rule number 2 is a classic we see everywhere in life, the law of diminishing returns. Sure, giving an AI more compute power helps, but only up to a point. Performance shoots up, then it flattens out, and sometimes, if you give it too much, it can actually get worse. So finding that sweet spot for every single task is absolutely essential. And that leads right into rule number 3, the domino effect. The quality of work you get in early step has a direct impact on all the later steps. If your retrieval AI does an incredible job and finds the perfect source material, well, the generation AI's job becomes way, way easier. It might need a smaller model or fewer tries, which saves you a ton of budget down the line. It's a chain reaction. So now that they had this 3-rule playbook, the researchers could actually build a solution. So let's meet the star of the show, AgentTTS. It's the AI manager designed from the ground up to put these rules into practice and solve that compute puzzle all on its own. So what is it, really? Think of AgentTTS as an AI agent that's a genius project manager.
Its entire purpose in life is to automatically figure out the best, most efficient mix of AI models and budgets for any complex job, learning and getting smarter with every single attempt. And the way it works is this really elegant, simple loop. First, the agent, using those 3 secret rules, decides on a few team combinations to try out. Then, the environment actually runs those teams on the real task and reports back on how well they did. And finally, the archive stores all of those results, building up this massive knowledge base so the agent gets smarter and smarter with every cycle. Okay, but the big question is, does it actually work? Is this AI manager any good at its job? Well, let's look at the results, because they're pretty stunning. This is where we really see the power of working smarter, not just bigger. Check this out. The difference in efficiency is just huge. Other methods kind of wander around, taking about 40 attempts to find the best solution. But AgentTTS, because it's using that smart playbook, it just zeroes in on the perfect team in only 10 trials. That's a 4 times improvement, 4 times faster. And it's not just faster, it gets better results. When they put it head-to-head with another top method, AgentTTS found a great solution in just 2.5 hours. The competition took over 8 hours. But here's the kicker. The solution AgentTTS found actually performed better on the task. So it's faster, it's cheaper, and it's more effective. That's the trifecta. And this all boils down to one really powerful idea. The next big frontier in AI might not be about building ever larger models. It's about orchestration. The big breakthroughs are going to come from building these intelligent systems that can manage the amazing tools we already have, deploying them with the skill and efficiency of a master conductor. Which leaves us with a pretty wild thought to end on. We've just seen an AI that can teach itself how to manage other AIs to do a complex job better than we could. If AI can start managing itself this well, what does that unlock? What kinds of massive, world-changing problems suddenly become solvable when our tools aren't just powerful but also smart enough to manage themselves?